Hello. Okay, now you should see the desktop and you should be able to hear me. Uh, is this everything seem okay? So everybody can hear me? Let's see. I got my speaker turned on. Okay. Does everybody hear me? Is everything seem okay?
Yes.
Okay, great. Thank you. Okay, let me pop up another window. Okay. There. Okay. So today we're going to be talking about this section from way back here. The reading assignment was last week, actually just before spring break. So we're going to be talking about nested for loops today. Okay. So we're going to probably spend this week we're going to spend this whole week talking about nested for loops. And the last thing we did was loops on strings. Okay, and that's a real nice example of using loops. Now, nested for loops is a real general thing. We'll see in a minute what I mean by it, but it's a huge part of programming. Okay, so walking strings is just one example of how you might use a for loop. It's a real common use of a for loop. So walking strings was practice in using for loops. Okay? But nested for loops is a much more general idea, something that gets used. It has to do with tables. We'll see in a minute that nested for loops is when you have tables of numbers. A lot of times that brings up nested for loops. Okay, so there's no new reading assignment because we're going to be doing this stuff here for the whole week. So actually, there's no new reading assignment. Though I'll put up some problems from um, Coding Bat soon. I'll give you some more Coding Bat problems to look at. Okay, and now these two reading assignments weren't much. Remember, these are just more or less summary sections. So there's not that much in them. And then we won't really do this till next week. Okay, so we'll be talking about this today, even though. So we're going to we've talked about methods. This is a review section on methods. So we're actually going to start introducing methods. We're going to start using them again. So even today, we'll see that we're going to start using methods a little bit again. So this section, we'll be using it off and on, even as we do the nested for loops. Okay, so let's start talking about the nested for loops. Okay, so just like we had nested if statements, now we can have a for loop inside of a for loop. So it looks, this is what it looks like as a picture. Okay, and we have what we call the outer loop, which is the one you write first, and then inside the braces of the outer loop, you put another loop, and that's called the inner loop. Okay, now I'm going to change. I've got some examples on my computer we're going to use on Java Visualizer. Okay, so here's a slightly different version of the same example they're doing. Let me start up Dr. Java first, show it in Dr. Java. So here's something real close to what they just did. Whoops. See the spinning arrow? This is when Dr. Java starts up in an infinite loop. So let me close it again. Start it up. Boy, half the time I start up Dr. Java, it starts up like that. Okay. And now it's okay. Okay, so there's another example of nested for loops, slightly different. Line 13 is the outer loop. Line 15 is the inner loop. Okay, the inner loop prints something. Now here they didn't print anything. See, they just printed a blank line. That's not very useful. So this one's going to do something just a little bit different. Okay, now here they use suggestive variable names like row and column. But at this point, we don't know why they're using the name row and column there. So I just use the letters I and J here. Okay, this for loop is using the letter I, and it's going to count from I equals 1 to 6. Okay, so it's doing 6 loops on I. And this one in here, I'm just using the letter J. Okay, and we'll see that, yeah, row and column were good names for these, but we're not quite sure why yet. Okay, So, so I'm just using the letter I and J. J goes from 1 to 4. The key thing is what's happening here compared to what's happening here. So the way to really do this is to run it, okay? Now, what I want to do is run it in the Java Visualizer so we can watch it run. So now I'm just going to copy it up to the Java Visualizer. Okay, visualize it. Okay, let me, oh, exceeded maximum, see, busy day. See, this one exceeded max visualization times. That means that they have a lot of people. Let me try it over again. There's probably a lot of people using their, see, it's gone this time. If you get these, sometimes if you get a funny error message there, just go try it over again. So there's probably a fair number of people using their server today. Okay, let me just jump to the last and see what this thing printed out. And what we see is it printed out something like a table. Okay, it printed out a bunch of output. Okay, now notice, remember they used row and column for their variables, and right now it kind of looks a little bit like a table, but it doesn't really, like I equals 1 is not row 1 because that's I equal 1, I equal 1, I equal 1, I equal 1, then I equal 2. I mean, I'm in the 5th row here. Okay, what we want to do is want to see eventually why they chose to call it row and column here. Why do they choose row and column? And it's gonna take a little while to get. They shouldn't have jumped the gun in a sense. They used the names row and column before they actually explained why they would use row and column. Okay, so notice that I'm right now. I'm just going to use I and J. Okay, notice this is what the output looks like. Okay, the key thing here is that, see how I have I equal 1, I equal 1, I equal 1, I equal 1. Okay, but then I have J equals 1, J equals 2, J equals 3, J equals 4. This inner loop was run with I being 1 in the outer loop. So remember what a for loop does, it says when this thing is true, do what's inside the for loop. Okay, if we want here, for, you have 3 parts of a for loop. Go back and remember real carefully what a for loop does. There's 3 parts of the for loop, and then the for loop has a body, okay? This part here is the test, okay? This part here is the initialization. And this part over here is the thing that increments. Okay. The idea is that you start off with some number, you test it, you hit your limit. If you haven't hit your limit, you do something. Now, in our case, the do something is going to be another for loop. Then after you've done something, you increment whatever your variable you're using, then test it again. Okay. Now what we want to do is in here, put another for loop. Okay. Now, a for loop is an initialization, a test, and an increment. And then now I'm going to do something. Now this is the do something of the inner loop. Now we know exactly what the do something from the outer loop remember, so we started with a loop that looks like this. The do something here became this loop, but this loop does something over and over again. Okay, notice that this thing is going to be done essentially the product of however many times this thing loops and this thing loops. Okay, see, suppose we say, let's make it more specific. I equal 1. Test that I is less than 5. and then we'll increment I. Okay, do something, right? Now, inside there, let's put something more concrete. J equal 1. Let's test that J is less than 4. And then we can increment J. Okay. Now, this do something is done 4 times by this loop. Okay. But this loop is being done 5 times by this loop. So do something is being done 20 times. No, yeah, 20 times. Now see how it works? For each value of I, you do this thing. So when I is 1, you do this, which does something 4 times. Then when I is 2, you do this, which does something 4 more times. Then when I is 3, you do this 4 more times. Okay? Okay. So
Oh, wouldn't it have to be less than or equal to make it?
oh yeah, you're right. Yeah, if I actually wanted to make it 20 times, it's supposed to be less than or equal to there. Okay, great. Yeah. So see, the idea is that when this thing gets a value, you do what, see, every time this thing gets a value, you do what's inside. But if what's inside is another loop, then you're going to repeat what's in, you're going to do something else. Okay, so when this number gets a value, that means do this loop. Okay, then this number gets another value, so you do this loop again. And it's the order is pick an I, then do this, which takes J going from 1 through 4. Then pick another I, then do this with J going from 1 to 4. Okay, now that's what we saw in our output over here. Okay, if I look over here on the left, first I was 1, then J went through up to 4. Then that would be this inner loop. Then I became 2. Then after J went 1, 2, 3, 4, then I became 2. Then J becomes 1, 2, 3, 4 again. Okay. Then I equals 3. Then J becomes 1, 2, 3, 4. So we pick an I, and then for each value of I, we do what's inside here. And what's inside happens to be another for loop. So that means start going through all the J's. Okay, now let's watch that actually happen. Go back to the beginning here and just what? So we start with I equals 1. Then we go into the for loop and we start with J equals 1. Okay. Then we go into the print and we print our first line. Then we go back and make J 2. Notice that I's staying at 1. Print another line. Go back, J equals 3. Print another line. Go back, J equals 4. Print another line. Okay, now J is 4. Now we're up here at the increment. So J is going to go to 5. Now we're at the test. This test fails now. We've done our J equals 1, 2, 3, 4. So the test fails. So now we're going to go back up here to line 5. See, so we did the inner loop once. Go back to the outer loop. Now the outer loop picks up another value. Oh, notice that J disappeared. Why did J disappear?
Because J only matters to that one loop.
Yeah, when you declare J inside the for loop, it only lives while the for loop is living. Now that's the difference between declaring it inside the for loop or outside the for loop. Okay, since I declared it inside the for loop, when I get to the end of the for loop, the J disappears. And then when I start the for loop up again in a second, I'll get a new J essentially. Okay, so now I'm going to I2. Now I'm going to test 2 is less than 6. So 2 is going to be less than 6, so that's going to take me to line 7. Okay. Now I'm at line 7 in the initialization part. So now I'm going to create another J back at 1. It's essentially a new J. It's a J, but you know, we actually think of it as a new variable called J, okay, and it starts at 1. Okay. That J, it's important to know that J disappeared when this loop ended. If we don't want it to disappear, sometimes we don't, then we declare j, say up here at the beginning of our program. If we don't want this j disappearing on us when we leave this loop, we can make the j declared up here, for example. Okay, so now I'm going to start another round of j's. J is, I just made it 1. 1 is less than 4, so I print. See, now I2 J1, I2 J2, I2 J3. Okay, now last time through. Okay, now I'm up here. I'm at the increment part right now. I'm at the increment part. I'm about to increment j to 5. Now I'm going to the test part. 5 is not less than 4, so I'm going to fail the test and go back up here. Oh, now I'm up here. Now I'm ready to increment I once more. Now j disappeared on me. Now I can increment I to 3. That was this part. So now I'm going to go do this part. Okay, 3 is less than 6. So I'm down here and I start another round of j's. Okay, so holding I fixed. Now notice that one thing, the way you should think about it, in this loop, I doesn't change. Okay, in this, now I is changing out here, but it's not changing while you're doing this loop. I changes when this loop is done and you go up here. And this is what causes a lot of confusion is, when does I change? I is a variable, it's changing, but it's not changing while you're doing this loop. It changes after you leave this loop, then you change I, then you go back into this loop and start it up again with a new I. Okay, it's important to realize that some people mistakenly think that these things change in parallel. Somehow that you do I is 1, j is 1, then I is 2 and j is 2, then I is 3 and j is 3. People look at this and think that I and j are changing essentially together, and that's not what this means. Okay, I and j don't change together. I changes and then j runs through its course of numbers, then I changes, then j runs through its whole course of numbers, holding I fixed, then I changes again, and then j runs through its whole course of numbers. Okay, so like we've run through the j's twice now. We're about to do a new round of j's. I is 3 now, and now we're going to do another run of j's. Okay, there's the run of j's. Okay, j is 5, so we're done with that run of j's. Up here, I is going to become 4. Okay, and then you just keep on going. Okay, now I is 5. Okay, now I is 6. Last run. Okay, now I is 6, j is 4. I'm in here. Oh, actually, I need to fail. I need to do one more. Okay, now j is 5. Oops. J is 5. So this loop is ready to be done. So I'm going to go back up to here. Okay, now I'm in the increment I. I is going to go to 7. Now I'm about to go over here. 7 is not less than 6. So this is going to fail and the program done. Okay, and we get these outputs. Okay, all right. No, we don't have yet. Okay, now we see what the idea of a nested for loop is. Choose the value of your outer loop, run through the inner loop. Then change the value of the outer loop, run through the whole inner loop. Okay, so it's choose a value from the outer loop, run through the whole inner loop, change the value of the outer loop, run through the whole inner loop. And until you get used to this, every once in a while you'll fall into that trap of thinking that the I and J are changing together. I1, J1, I2, J2, I3, J3. Now that wouldn't work when these things have to, like if this was up to 15, it would be kind of hard to figure out how that's going to work. If this one goes up to 15 and this one only goes up to 4, how can they change together? Okay, so it doesn't really make sense, but a lot of people fall into that trap of thinking that the I and J are changing together. This would do something 60 times, 4 times 15, because there's, for each one of the I's, there's 15 I's, you do 4 J's. So for each of the 15 I's, you run through 4 J's. So that means you do something 60 times. 4 times 15 is 60. Okay. Now, when you do something, you usually want to keep track of which I you have and which J you have. The I and J will affect how this thing works. Usually, you're not just doing the same thing 20 times. If you just wanted to do the same thing 20 times, you would probably do this. Okay. Yeah, this does something, right now it's 60 times. Okay, and this does something 60 times. But these are really different. Okay. When you're doing, this something is going to use the I and J. And it's going to know that I is actually going from 1 to 15 and J is going from 1 to 4. And that's going to affect how it does its something. Whereas here, this does something 60 times, and there's just an I going from 1 to 60. So here I'm just making use of one parameter, the I. Here I'm getting two parameters. Okay? And if I wanted to be really tricky, there's no reason why I can have just two loops. Let's see, I want to do 60 times. See, what's another way of getting up to 60? I could do 10 times here, 2 times here, notice I'm still doing something 60 times. I'm doing this thing 10 times. For every one of these, I do all of this in here. Okay. Now, how many times does this work? Well, this is just 2 nested for loops. We know that that means this will do 6. 2 times 3 is 6. So this will do this 6 times for each one of these. So that means that this thing's done 60 times. So this is 60 times. This is 60 times, and this is 60 times, but this one's got 3 parameters. This one you can use I, J, and K. This one can only use I. This one can use J, I, and J. Okay, and eventually we want to see how we can make use of that. We're going to do something 60 times here, but using 2 parameters. Something we're going to see, it's going to usually be, a lot of times I have that many rows and that many columns in a table. Now, remember in the book, they start out by drawing this picture with the words row and column. A lot of times it has to do with a table, but not always. Okay, a lot of times it has to do with a table. Okay, so this would let me have 15 rows and 4 columns, or maybe vice versa, 15 columns and 4 rows. You don't even have to have it. You don't have to have it outer one be rows, inner ones be columns. If you have a table, you could have the outer one be columns and the inner one be rows. You're not forced to. Okay. Here I'm just saying I's and J's. Okay. So I'm going to do 15 I's, and for each value of I get 4 values of J. Here I just get 60 values of I. Okay, so that does something 60 times. I only have one parameter to work with. Here, for some reason, I may have, this would be like a cube. We'll see that this is very much like walking through a cube. Yeah, you can imagine this as being if you have a building, if you think of this is one dimension of a cube, walking along one side of a cube. This would be walking along another. If you think of stacks of building blocks, and it's 10 stacks, the stack is 10 high. It's got, each stack has 2 columns and 3 rows. Okay, so another way to think of it is this is a table, and then there's a stack of 10 tables. Okay, so sometimes we work with this, and we think of rows, columns, and layers. Okay, But the idea is here that I'm going to do for every one of these i's, I'm going to do this thing. But this thing says pick a j and then do this thing. And this thing says pick a k and then do something. But now you have the I, j, and k to tell you where you are in the loops. Okay, so this is the idea of what we're doing. Okay, and this output in the Java Visualizer just shows us that this one's demonstrating not rows and columns. It's demonstrating that the outer loop picks a value and you run through the inner loop. Then the outer loop changes its value and you run through the inner loop. Then the outer loop changes its value, then you run through the inner loop. Okay? All right. Now, let's modify this a little bit. Okay? Let's see. Okay. Suppose, like, look at this program here. If I run this program, I'll just run it here in Dr. Java. Oops. Oh, because I can't now. Remember, this one's not a legitimate Java program, so Dr. Java is not going to let me compile this one unless I close this one. So let me just take this one and copy it to the Java Visualizer. Okay, real simple program, no loops or anything. And what it does is it prints, what looks like, you can think of this as a little table. It's a table of 1, 2, 3, 4 rows and, well, 4 rows and 1, 2, 3, 4, 5, 6 columns. Okay, so it's a little table of 4 rows and 6 columns. Okay, and every entry in the table just has a star in it right now. Okay. Okay, now let's imagine how we would do this with for loops. Okay, so yeah, if I run this, I get that output. Okay, now let's see, I'm doing the same thing 4 times. So a good programmer says there's no reason to do the same thing 4 times. Let's go ahead and ask a for loop to repeat it for us 4 times. So let's say for int I equal 1, I less than or equal to 4, I plus plus. Okay, and then we can visualize this and we get the same output. Okay, but we got it by a for loop now. Now we're going to loop 4 times. I'm not using the I, I'm just using the I to keep track of how many times I've done it, and I'm just going to print that 4 times. Okay, now let me change this inside a little bit. I want a row, I want 6 stars in a row. Here's a kind of dumb way to get 6 stars in a row, but it turns out to be not too dumb. One, oops. There's 1 star, 2, 3, 4, 5, 6. That gives me 6 stars in a row. But I also want there to be a blank line at the end. So I'll do a print line at the end. Okay? Right? So now my for loop says, do this thing 4 times. But each time I go through, I print star, 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 blank line. Okay? All right? And if I loop through this, I is 1, print star, 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 end of line. I equals 2, star, 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 star. Okay, so I'm building the line step by step. Okay. Okay. All right. Now, but notice how that was a repetition of something. So there's a loop. So let's take that and replace it with a loop. So now I'm going to say for j equal 1, j less than or equal to 6. I want 6 of these guys, j plus plus. Now, I need to switch to a different letter here. I have to be careful I don't reuse this letter. The inner loop needs its own counter. It can't somehow make a mistake. It's a mistake to use the same counter in both your loops. Now, there's going to print the stars 6 times. Notice, now I'm not going to get rid of the print line because the print line wasn't part of the repetition. It was star, 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 print line. The print line wasn't part of the repetition. So now the repetition is print star. Okay? All right. Now, if I visualize this, whoops. Oh, I forgot to declare it. See, forgot to declare it. If I do this, it's okay, but then I'd have to declare it somewhere else in the program. That's not wrong to use a variable without declaring it in a for loop, though we tend to prefer that our for loops have their variable declared in them. That's usually considered good style. Every once in a while, you want a for loop where the variable's not, maybe I could declare it. This would be valid, but it's not really a good idea. Declare j way up here, then use it way down here. Now this will work. See, it'll work fine, but it's considered a bad way to program. I'm declaring j up here, I'm using it down in here. It's way better to just declare a loop variable in its loop. You don't have to, but it's a wise thing to do. Okay. Okay, now how does this work? Outer loop. Now, the outer loop's really telling this guy to print 1 row. So from the point of view of the outer loop, everything inside of it prints 1 row. And it does it by printing stars, star, across a row until it, when this loop is done, then it says, okay, now we need to go back to the beginning of the line. Okay, now we're actually, you don't see it out here, but we're at the beginning of the next line. And now the outer loop says, do it again. Okay, so now I'm on my second time through the inner loop. Now I declared my j for the inner loop. Start stepping. Now see, I'm on a second line now, and I step through the inner loop. Okay, there's the last star in the inner loop. Now I need to end that line by going back to the beginning. Okay, but now you can kind of see that I'm building a table. Row by row, column by column, I'm filling out a table. Okay, now, for example, if I want, one way to see that I'm kind of filling out a table is to print, say, instead of printing a star there, let's print J. Let's see what we get. What will we get if we print J there? What's the output going to look like now? Instead of printing a star, I printed J. What will I see in the output? Try to think before, because you need to practice thinking about for loops. What's this thing going to do? Pick an I, pick a J, then what's this loop do with the J?
Print the
It'll
number.
print it.
So what do I see out?
1, 2, 3, 4, 5, 6.
Okay, that's one. Okay, that's one trip through an I. Then what happens when I go through here again?
Same thing.
Same thing. So what do I see in my output?
1 through 6 and 4 rows.
Yeah, four rows, where each row is 1 through 6. There they are. See, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3. Notice that now you're starting to see why they called this outer one row. See, now you're starting to see why they thought of it as a row. If you don't step to the next line in your output, you're staying on 1 row. So until I move to the next row, I'm sort of staying on 1 row. Okay, so no, but it's really this guy that takes me to the next row. It's kind of weird. I mean, this is not really a row variable, but it becomes a row variable because at the end of the inner loop, I put a new line that says, okay, go from 1 row to the next row. This thing really makes it become rows. For example, what happens if I get rid of that guy? Okay, What happens if I get rid of this guy? Tell me what the output's going to look like now. I didn't change the loops. I got rid of that one line.
What line did you get rid of?
The line that's commented out, 11. That was the line that started the next line. So what happens now?
It's gonna be 1 through 6 all in the same line.
All in the same line. Yeah, there's no rows left now. Even though it's going to still repeat all the time. It's going to be repeating, but there's not going to be rows like like here. See, you know, they call it rows and columns, but you got to be very careful. Now see, they put a system.print line right there. That actually is what made it rows and columns. They're not rows and columns automatically. See, they had that print line there. So after this output, there was a start another row. Okay. All right. Now, if I look at the output here, see, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, all in one row, but it's still from this nested for loop. Okay. Let's do another little puzzle. Put back that guy. Print I here. Now, what do I see in the output?
See, 1. You'll see like 1, 2, 3, 4, 5, 6. I don't know, 1 through 4. And there's gonna be 6 of the numbers in 4
Yeah,
rows.
but you haven't. But yeah, be real. Yeah, you're saying the right words, but they're in the wrong order. Be real careful. What do you see in the output?
You're gonna see 1 6 times in 4 rows, and then 1 6 times in a row.
In what? 1 6 times in
The same line,
the same row. Yeah.
Yeah.
Then
2 all the way to 4.
yeah. So you see a row of 1s, a row of 2s, a row of 3, and a row of 4s. See, there'll be 4 rows, but each row will be the same number, I, the row number. Row of 1s, row of 2s, row of 3s, row of 4s. Okay. All right. So we're printing tables. We are printing tables with rows and columns, but you got to be careful. Okay. See, for example, if I now go back and get rid of this one, it's not going to be a table anymore. Oops, not that one. Now, what do I see? If I hit last, I got rid of that print line. So what do you see?
It'll have all on the same line, 1 6 times, and then 2 6 times, and 3 6 times,
Yeah,
and then
it
4
won't be
6 times.
it won't be a table. It'll just be one row because there's only one print line. You know, so there's only one row, and it's going to be 6 1s, then 6 2, because I will go from 1 to 2 to 3 to 4. But when you have I as 1, you do this 6 times. So you're going to have 6 1s followed by 6 2s followed by 6 1s followed by 6 2s followed by 6 3s followed by 6 4s. Okay. Right. Now this is the kind of thinking we have. You'll notice that we have to look at that code and analyze it pretty quickly. You know, the idea is to start getting used to looking at that code and thinking in terms, what does it do? Now, with that line there, it becomes this becomes a row. And it becomes a row because I terminate it here. Now, here's another problem I can do. What if I do this? Am I going to get a nice table now?
Yes.
Anybody, will I get a nice little table? 4
Yes.
rows and 6 columns?
Yes.
Why?
The same, everything in the same column.
What column is that?
The first one.
Yeah, everything's in the first column because this guy here, see, I didn't print them all on the same line. So now everything's on everything, you know, everything gets printed and immediately go to the next line. Everything's in one column now. But notice that What did this guy do? What was his job now?
Add a space in between them.
Yeah, he added that blank between like the outer loop and the inner loop. He put a little, his job now is to put a blank line between them. But I don't have a nice table, unless you think that's a nice, yeah, you can still think that's a table, but it's got only one column. Okay, so it's a table of just one column and a lot of rows. Okay, that's because here I wasn't really building a line every time through the loop. Every time through the loop was one line. The way it was before, see, print stayed on the same line, so this loop did everything on the same line. Real important. Since it was print, this loop did everything on the same line, then this one went to the next line. If you go back to their picture over here, that's what they're real carefully doing. See, print there, so that's all on the same line. Then this guy goes to the next line. So then you could think of this is picking your row, and this is doing a column in the row. It's doing a column in the row because it's print, not print line. And this is doing a row because of this print line at the end here. So it's rows and columns because of how carefully they wrote this. Print here, print line outside of that loop. But if you just write nested for loops, you may or may not get rows and columns. You can write nested for loops. You don't have, yeah, we just saw you can write nested for loops with print line there. And then you're just printing out one long column. You know, then you're printing one long column with a space between pieces. There's the inner loop once, space. Then there's the inner loop a second time, space. Then the inner loop a third and a fourth time with a space between them. Okay. Now these things are not these things are not trivial to read. You know, reading these things can be tricky. You know, they are rows and columns if you use them in a very specific way. So, and a lot of times that's what motivates nested for loops is this pattern of rows and columns. But it's important to know that it's not always going to be, just because you see two for loops, nested for loops, doesn't mean that you're creating a table. It could be you're creating a table, but it doesn't mean you're creating a table. Okay, now let's see, what else can we do here? Okay, now we can change the numbers here. I can change that to 6 and that to 4. Okay, what do I see now? I's going from 1 to 6. For each choice of I get 4 of something in a row. Oh, let me get rid of this one. That makes it. For each I get one of these. And one of these is 4 in a row of I. So it's 4 in a row of I. So what do I see output?
You see 4 ones and then 4 twos all the way down to 6, but each number is on each set of numbers is on a different line.
No, I took out that little printout. Oh, well, I see.
But I mean, like,
yeah, a row. So yeah, so a
the
row
rows,
of
yeah.
ones, a row of 4 ones, a row of 4 twos, a row up to a row of 4 sixes. So I see 6 rows of 4 long, and the rows are a row of ones, a row of twos, a row of threes, a row of fours, up to a row of 5s and rows of 6. Okay, so a row of ones, a row of twos, a row of 3, row of 4, row of 5, row of 6, and the rows are 4 long. This is the length of the row. Okay. What do I get now?
You get 100 on each row.
Yeah, I get 101. Now I don't. Maybe that might be too much for. Notice let's try. Let's see if it'll let me do it. It might be that they're not going to let me do this many. Yeah. See, I only got through the middle of the second row, and they stopped me from running. Okay, I only got through the middle of the second row, but it should have been. I mean, I could put this in Dr. Java. It would be 6 rows of 100 numbers each, the numbers 1 through 6. So it'd be 6 rows where each row is 100 numbers, 100 ones, 100 twos, 100 threes, 100 fours, 100 fives, up to 6. And they're probably not going to let me visualize that. This time I got, no, I didn't, I still got only like the first, I only got through the middle of the second row. Then they stopped my program from running. You know, you could maybe something shorter. So I got 3 rows of 50. I got a little bit more. Each of these is a row of 50. I got 3 and a little less than 3.5 rows. They don't let you run very large programs on their server. Yeah, it's meant for just visualizing small programs. So they have real strict limits on how big your program can be up on their server. Okay, all right. Here's something that's kind of, what if I do this? I'll give you, I'm not going to get a nice little square table of output. Why not? Think of what, okay, what's it going to print? What does each inner loop give me?
It prints 1 4 times, and then 2 4 times all the way down to 12.
4 times, yeah. What's going to stop me from getting a nice little rectangular table? Anybody see something's going to go a little bit wrong? I'm not going to get a nice little rectangular table. What happened to my rectangle?
Because you add a couple 2-digit numbers at the end, the rectangle's now an L.
Yeah, because yeah, and this is going to be a problem for us when we want to print tables, and the numbers sometimes have 1 digit, sometimes have 2 digits, sometimes have 3 digits. It's going to be a little bit tricky to print a table that way. I really would have needed to use an extra space up here. See, I really needed to print out something like 0 or put a blank. I really needed something that would put, I can't edit down here. Yeah, they don't let me edit down here, but to make that a nice little table, you know, see, I would make it a little table by putting this like this. See, now I'm making it rectangular, but I have to account for the fact that some of my numbers have 2 digits and some of them have 1 digit. So I need to put a space in front of the ones that have 1 digit. And now I can make it, now we'll learn how to do this in Java. Like right now, we don't have any sense of how would you get Java to do this for you? Okay, there, see, now it's a little square table. Yeah. If I wanted to, I could even fill in that with a 0, and it's still, see, 0, 9 is 9, 0, 9. So I could fill in that empty spot in lots of different ways. If you're really wanting to make a table, another way you might fill in an empty spot is put an underscore there to say, oh, that place is blank. But, you know, eventually we'll want Java to do those things for us. We don't want that kind of messed up output. We're trying to print a table, but some of the numbers are 1 digit and some of the numbers are 2 digit, and that kind of messes up our table. And that's actually a very important problem, to be able to print your tables in nice formatted ways. So we'll see as we do more examples of a way to get this thing to, and Java should be smart. Java should allow us to put a blank, a space there, or an underscore there, or a 0 there, depending on what we wanted. How would we fill in the, how do we get the columns to align up? See, there's a 2-digit number, so I need 2 digits above it, but there's only 1 digit, 9. So you need to, what we say, pad it. You have to put some kind of padding here. The padding can be a space, the padding can be an underscore, the padding can be a 0, because 0, 9 is still the same thing as 9. Okay, so yeah, so right now we're just playing games with these for loops, and you want to think about them. You know, the important thing is to think about what they're going to do. Okay, now let's look at another example. Let me take this example, and remember I said we're going to talk about methods every once in a while. Okay, now let's go back. Oh, okay, here's the example in the Java Visualizer. Notice that there's several things I could play games with in this thing. I can change this number here, how many rows there are. I can change this number here, how many columns there are. And I can change what I print there. I'm going to print a pound sign. There's a table of pound signs. Okay, now I want, say, 3 rows of 15 @ signs. There's 3 rows of 15 @ signs. Okay, now, so I've got 3 things that are worth changing in here. So the thing to do is say, well, this is what methods are for. Methods are for letting you say, I want to have that a parameter, and that a parameter, and that a parameter. Okay, so let's turn this thing into a, okay, let me get the example. So I'll put it up on Java Visualizer. So let's take this example and modify it a little bit using the idea of methods. Okay. This is the same thing as this. Okay. There. What's highlighted here and what's highlighted here are essentially the same thing, but on the other page, the 3, the 15, and the @ sign become how many rows I want, how many columns I want, and what letter I want. And those are now parameters to a method. This is how methods can be real useful. If I like this guy and I want to print out all kinds of different tables, instead of constantly having to edit this code and recompile the program, I can take that code and wrap it in a method. And the method is called nested for loops. It says, here's how many rows I want, here's how many columns I want, here's what letter I want it printed over in the table. Okay, and then over here I can call it, and then I can call it as many times as I want. See, now I can call it over and over again. And I should put a, let's see. See, if I visualize this, there's my tables, but they don't look like, it looks like one big table. What would be nice is we put a blank line between them so I could see where one table started and one table ended. So what I should do is, like, that's the thing that prints a blank line, put one of these between here and here. Okay. So my method prints a table, and then I put a blank line in between the tables so I can see them real clearly. But now I can also make my tables different sizes. Make this one 4 by 6. Make this one, say, 8 by 3. Okay. See, I can easily notice how much less code that is to write to say nested for loop, 6 rows, 4 columns, pound signs. Nested for loop, 4 rows, 6 column @ sign. I mean, I could literally just copy this loop over and over again and change what numbers here, change what's numbers here, and change what letters there. But the whole point of methods is that's what methods do for you. They let you call this code with different values there, there, and there. And notice here, okay, what? Okay, let me just look at the output. There's a table of 6 rows and 4 columns, then a table of 4 rows and 6 columns, then a table of 10 rows and 3 columns. Okay, so there's my, or 8 rows and 3 columns, 8 rows and 3 columns. Okay, now let me show you, real important, look at the way I use the word rows and columns and compare it to the way they did. This is actually a little bit, yeah, there's two kinds of ways to use the variables. Here, notice that row is the loop variable. Row 1, row 2, row 3, row 4, okay? And 3 is how many rows there are. Then, given any row, this is the column counter. You start at column 1, then column 2, then column 3, then column 4, and 5 is how many columns there are. Over here, I switched I use rows and columns, but I'm using them to how many there are. So I is the row counter. I is 1, then I is 2, and I is 3, up to that many rows. Okay. Then J is the column counter. Okay. Now, what if I want to combine my idea with their idea? So the variable here, see here, I would know that I is a row. So what if I type row here? Well, I can't have 2 variables called row. This is one variable. Well, actually, this one's rows. So I could kind of get away with like this. Row equal 1 up to row less than rows. Column equal 1, column less than columns. Okay, so I can do it this way. So I'm using a row, but this is a little, not everyone would like this. Row and rows are too easy to, they're too close in names. Like this one's not so bad. Column and columns, you're not likely to mix those up. But this is a little bit, this could be dangerous. You could easily get row and rows mixed up. This is the variable that says I'm in row 1, then I'm in row 2, then I'm in row 3, up to that many rows. I'm in column 1, then I'm in column 2, then I'm in column 3, up to that many columns. Okay, all right. So that'll still work. Whoops. Oh, but then I have to change these guys. So increment row and increment column. Okay. Okay, and I get the right output. Okay. So when you want to work with, a lot of times you can when you have code where you can see that there's, oh, it's worth changing this, and it's worth changing this number, it's worth changing that number, it's worth changing that number, because this is how many rows there are, this is how many columns there are. Notice it's not worth changing that number. What if I change that, would that be, can you think of any good reason to make that one of your parameters? Would it be a good reason to make this guy a parameter? Casey, why would it probably not be a good idea to introduce a parameter for that? It's a number. What if, what if I changed it? Then we see what that's going to kind of goof up.
Could it give you a logic error about the number of rows?
Well, it wouldn't, it would mean that the row counter, it would mean that this number is not how many rows there are. Because if I change this to, say, suppose I change it to 3. How many rows are there now?
You mean for the first of them, there'd be, I think, what, or 4?
Well, in general, okay, cover up the top part. Just look at this loop and tell me how many times does that loop iterate?
However, however many, like, rows minus 3 or
Yeah,
something.
exactly. Rows minus 3. Okay, so how many rows do I have? Well, it's not this number, it's this number minus that number. So if I made this number a parameter, okay, like okay, Bob. I like the name Bob. So I create a parameter int Bob. Okay, I got a parameter for this one and a parameter for this one. Now my method is really flaky because what do Bob and Rose do now? Have I gained anything by, oh, there's a number in your code, give it a name and make it a parameter? I don't have a logic error, but I do have something very flaky. How many rows of output are there?
Rows minus Bob.
Yeah, that extra parameter didn't really give me an extra thing to control. Now I have the number of rows is now rows minus Bob. It's the same thing as if I just, like suppose Rose was 10 and Bob's was 4. I'd get 6 rows of output. I haven't gained anything. I just have a more complicated way to describe how many rows of output there are. Okay, even so, not every number over here is really a good candidate for a parameter. That was a good candidate. That was how many rows there are, assuming you started counting at 1. So you don't want to change the 1. That's how many columns there are, assuming you want to start it, assuming you count from 1. You don't want to change what that thing's count. If you change where you're counting from, then this is no longer necessarily 15 columns. Okay. Now, this was a good thing to change because it changed what I was printing. So I look at this code and I think, oh, that's something I would want to change. That's a number I'd like to change. That's a number I'd like to change. That's a character I'd like to change. I don't want to change that. Making a parameter Bob was a dumb idea. Just because I saw a number here doesn't mean that that thing should change. Because also now Bob and Rose together just determine how many rows there are. Okay, so not every number is a good parameter. Not every number is something you'd want to have changed. So you learn to like look at code and see where are the interesting things that are worth changing. This one, this one, this one, but not that one or that one. Okay. All right. So we can see how methods can play a nice role here. Once we've got these for loops that do something like this creates a row by column table. It creates a table with that many rows, that many columns, full of that letter. Okay, so that makes a nice little chunk of code. Okay, so we see now how methods can come back into play when we write these for loops. Okay, let's look at another example. Okay, here's something that's going to get a little bit tricky. Okay, I wrote it as something with a method. So here's my new nested for loops. Here's my new nested for loops, but I put them inside of a method so that I could call them different ways. Okay, so let's figure out what's going on inside of this for loop. There's only one parameter. That parameter says, oh, it says rows, so somehow it should have to do with rows. Okay, so here I go from 1 to rows, number of rows. Okay, if we have this is 6, I'm doing from 1 to 6 here. Okay, so that's a row. Now, here's the thing that makes it ends the row. So one row ends with that. But notice that there's 2 loops here. See, as opposed to what we've been doing before, where there would be an outer loop and one inner loop. Now we got something with an outer loop and two inner loops. Okay, read them real carefully. What do they do? Okay, this inner loop starts in what we can think of as column 1. See, they're columns because these are prints. Okay, column 1 up to what? This loop starts in column 1, but then it stops where? What's I measuring? I is,
The amount of rows.
no, not the amount of rows. I is the what?
Just the row.
The row. What is the amount of rows? Which variable is the amount of rows?
Rows.
Rows. Yeah, this guy counts how many rows there are. This is numbering one of those rows. You're either in row 1 or row 2 or row 3 or row 4. So this is saying this is one of the rows. You pick one. Row 1, row 2, row 3, row 4. This is how many rows there are. Now this is what column you're in. You're in column 1, then column 2, then column 3. Up to what column? Where do you stop?
1 minus what row you're in.
Yeah, 1 minus what row. So what's that going to do? Think, what's that going to start doing? As you go farther down the table, so the row number gets larger, what does that thing do? That stopping point does what?
It prints more columns each row.
Yeah, it prints more columns. So this loop prints a longer row as the row gets larger. So at first it prints a short row. When I is 0, when I is 1, it prints a very short row. Then it prints a longer row and one longer row. So this thing's printing slightly longer rows. Okay, because it stops. Now think of it real. If you're in row 5 and you stop in column 5, yeah, so that's what it does. If you're in row 5, it stops in column 5 minus column 4. If you're in row 5, it stops in column 4. If you're in row 10, it stops in column 9. If you're in row 2, it stops in column 1. Okay, right. So this thing prints spaces up to 1 less than the row number. Okay. Now this loop's a little bit tricky. This prints some more. Okay. After this one stops, this one prints some more. Now it prints the number J. Okay. How many more does it print? Oh, now this gets tricky. It says row plus 1 minus I. Now let's just run it because now we're starting to see this is actually this is a good example of how tricky nested for loops can get. At this point, we've done enough thinking about it. It might be better if we just run it and then do some more thinking about it. So we've got a sense of what this one's doing. Okay, the outer loop's printing rows. Okay, there's 6 rows. This does the first part of the row up to the whatever row number you're on. This does the next part of the row. So each row is broken up into 2 pieces is what this is saying. Each row is broken up into 2 pieces, and then this ends the row. So let's put it in the Java Visualizer and see what it does. Let's just go ahead and look at the output, not step through the code. Let's look at the output. Okay. Okay, it printed a triangle-like shape. Okay. Okay, now here's these spaces here. That was the leading spaces in each one of these rows. See, there were I minus 1 space. So if you're in row 3, there were 2 spaces. Row 1, 2, 3, there's 2 spaces here at the beginning. If you're in row 1, 2, 3, 4, there's 3 spaces. When you're in row 5, there's 4 spaces. When you're in row 6, there's 5 spaces. Okay? Then that was what this loop did. This loop put those spaces at the beginning of each line, of each row. Then this came in then and finished off the row. This came in, finished off the row with a counter that started at 1. So you started counting now up to, well, the last number here. Okay, we wanted to end in row 6. So we did rows plus 1 minus I. We counted up from 1 to however many spaces there were left to do. So see, once we start with a 1, we want to count up to however many there's left to do. We don't want to go off the end of this. So this told us how many there were left to do to finish the row. So this started the row with spaces, and then this finished the row by counting from 1 up to the end of the row. And the end of the row is in column 6. Okay, so we get this kind of weird table, a diagonal table. Now we're starting to see tricky examples. See, now we're trying to, now we're writing some code that's not at all trivial. What we're going to do later on is we're going to say, if somebody gives you a picture like this, write the code that drew this picture. Here, we started out by saying, here's some code that's kind of weird and not easy to read. Can we figure out what this code does? We read as much of it as we could without running it, but then it started getting really complicated to analyze. And then it's saying, oh, let's run it, because it's starting to get really hard to figure out what it's doing. In that case, run it, see what it looks like, and then go back and think about what it's doing. Okay, so we ran it, saw, oh, it's doing a triangular table. This is the beginning of each row. Those are the counting the spaces. And then this one does the rest of the row, counts up from 1 to however many spaces there are left in the row. Okay, all right. The hard thing later on, if somebody gives you pictures like this, to write the code that draws them. So like here, if I do this with the number 9, I'll get that same table, count up to 9, then count up to 8, then count up to 7, then count up to 6, then count up to 5, but with blanks up in front so that the 1s go down the diagonal. And then the 2s go down another diagonal. So the 3s are going down another diagonal. Okay, so you get these kind of cute outputs. You could either, somebody could either give you this code and tell you to figure out what it does. More likely, as like coding back problems and problems we'll work on, usually somebody gives you the output. Somebody gives you the output and say, can you write code for me that'll generate this output? Okay, using for loops. Okay, right. So this is the kind of thing we want to. This is why we're going to spend the whole week. We're going to spend a little bit of time on this. These examples aren't trivial. When we don't want them to be trivial, we can definitely make these things tricky. Okay, let's do another one. Okay. Now look, here's the method, and look how much stuff is in there. And here's what it does. It prints out a picture like this. Okay. If the number 6, it prints out a picture like this with 6 rows, a blank line, then 6 more rows. It counts up, then it counts down. But when it's counting up, it counts the numbers on that diagonal with trailing dots. And when it counts up, then it counts up again. Yeah, it counts up, then it counts up again. But this time it counts up with a diagonal going this way with trailing dots. Okay, so it's a pattern, and the code is how to draw this pattern. Notice that inside there's lots of loops. Okay, this loop does the top half. Then there's a blank line. Then this loop does the bottom half. In a sense, that's this half is a table. It's got rows and columns. That loop does the rows. but the columns are broken up into chunks. Because if you think about a row here, there's 3 pieces to each row. There's a column that starts with space. There's columns of spaces, then a 3, then columns of period. Okay, so as you're going across this row, at first there's spaces, then a number, then periods. And as you go across this row, first there's spaces, then a number, then periods. Here's the for loop that does the spaces. Here's the number. Here's the for loop that finishes the row with dots. Okay. Now on the bottom half, it's very similar, but you've got spaces, number, dots, spaces, number, dots. But it's a different number of spaces. Like in the second row here, there's 4 spaces and 1 dot. In the second row here, there's 1 space and 4 dots. Okay. So in the second case, there's the spaces, there's the number, there's the dots. Okay. So we want to learn to break these problems up into chunks. And this does 1 chunk of the picture. This does 1 chunk of a row. This does 1 chunk of a row. Okay. And we build up these patterns this way. Okay. These are somewhat, you might think these are artificial problems because you don't see patterns like this. And how many times you see things like this in the real world? And these are good exercises, but writing loops this way is real typical in programming. There are lots of reasons why you need complicated combinations of outer loops and inner loops. Here, these patterns, pictures like these are good problems to do in this kind of course to teach you to think this way. Though in the real world, nobody draws these kinds of pictures, but we do write code that looks like this a lot. For various different reasons in more advanced situations, we write code that looks like this a lot. And so these are nice problems for motivating these kinds of, for code that looks like this. Okay, so we've finished. Okay, so we're on Wednesday, we'll keep doing more examples like this. What we're going to do is we're going to start doing, we'll start with a picture and then write the code. On Wednesday, we're going to do examples where we start with a picture and then we want to think what kind of code will give us that picture. Today, we kind of did it the other way around. We started with these loops and tried to figure out what they printed out. Then we'll switch to saying, here's what I want printed out. How do you write a loop that gives me that output? So that's what we'll emphasize on Wednesdays. I'll show you a picture and then ask you to see, here's examples, pictures like these. Write code that does that. Yeah. Output that. Output that. Output that. Or that. Or output a box. I'll put a box with a diagonal through it. Okay. So we'll start with patterns and ask how do we write nested for loops to draw those pictures. Okay. All right. So we're done. If you have questions, if there's any question about what we did, I'll put the code. I'll put these code examples up on the website. Look at them carefully. If you ever have questions about any of these examples, please send me an email or come to office hours. And I'm working on creating another homework assignment, so you'll see that up there. I hope it'll be up there by Wednesday. Okay. All right. I'm going to stop sharing and see you on Wednesday. And if you have any questions, send me emails. Bye.